So let us talk about this fifth module, that is the introduction to group theories. Okay, so this definition part, just read it out. Okay, so much thing I won't say. So see here, definition of group. What is it? So for a group to be okay, say let G be a non-empty set and star be a binary operation on G. Okay, so G is called a group if the following condition holds: A star B belongs to G for all A comma B. So we can say that G is closed under star. Okay, it will be like this. So here that star thing will come. So B is closed under all that thing here. A, B, A, B like that. Then A star B, okay, this whole thing star C should be equal to A star B star C. That is the associative property. Then also you should have that, what to say, there exists E belongs to G where A into E is equals to E into A is equals to M. This is nothing but E is an identity element. Okay, so if I multiply E with anything, okay, that something that anything term itself will be my actual answer. Then for each A belongs to G, there is an element A inverse which belongs to G such that A into A inverse equals to A inverse into A will give me identity element. Okay. Now note the group is denoted by only capital G or in this brackets G comma star. Okay, so if AB is equals to BA for all A comma B, then G is called commutative or abelian group. Okay, so it's like a symmetric thing should be there, right? So it is commutative. Now let us see a question. So show that the fourth root of a unity is an abelian group. They might just give like this, or they might give a set W4 is equals to 1 comma minus 1 comma I comma minus 1. So that is an abelian group. Now first what I will do. So I'll say let W4 is equals to 1 minus 1 I minus I be the set of all fourth root of unity. So the operation star or this x both are same, multiplication of star for the whole okay, for the usual multiplication on W4 is as shown below. So this is one operation, binary operation multiplication like this. So 1 minus 1 I minus I, I'll write here 1 minus 1 I minus I. So simply multiplication I will do. Remember here 1 into 1, anything into 1 is that something number itself. Minus 1 means it will become minus. So here one thing let me say I into I, what will be the value? I into minus I, what will be the value? See, when the signs are same, both are positive, or suppose both are positive, so I'll have plus, sorry, I'll have 1, sorry, minus 1, okay. If both have different signs, then it will be minus 1. Sorry, I said ulta man, shit. Hey, Anna, yeah, it's correct, right? Now it's correct. If it is same sign, then I will have minus 1. If it different sign, I will have plus 1. Okay. Remember that. Same signs, both are positive, or I'll get minus 1. If both are negative only, I'll get minus 1. If there are distinct signs, then I'll have plus 1. Now let us multiply. So here, 1 into 1 I have to write. 1 into minus 1 is minus 1. 1 into I is I. Minus I into 1 plus 1 is, what to say, minus I itself. So I can say that when I multiply all this term with 1, I am getting that term itself. So I can say as my identity element. Now 1 into minus 1 is minus 1. Same normal notation. Minus 1 into minus 1 will become plus 1. I into minus will become minus I because this is negative. Then minus into minus will become plus I. Similarly, 1 into I is I, like that you will multiply. So now here I will show only the I multiplication. This I and this I into I. When signs are same, then I'll have minus 1. When signs are different, so I'll have plus 1. Same way, minus I into I. Signs are different, I'll have plus 1. If minus I into minus I, signs are same, then I'll have minus 1. Signs are same means minus 1. If it is different means plus 1. Remember that, this trick. So from the table, it is clear that W4 is closed under this binary operation star. That is A comma B, for all A comma B belongs to W4. And A into B also belongs to W4. If I multiply, see, whenever I multiplied, I didn't get any new term here apart from these 4 sets. So I can say that A into B, suppose A into B, so A are all this AI, into bi belongs to the same set W4. Since x is an associative in the set of complete numbers, so this is if you write like that, then you have to show that uh, 4 to 20, so is an abelian group. So what you have to show? You have to show the inverse thing, commutative thing, and associative thing, which means AB, if AB belongs to W4, then even BA should belongs to W4. That you have to, that thing they have written in theory part. So since star is an associative, okay, in the set of complete complex numbers, it is associated in W4. That is A comma B, A B into C belongs to W4. So here you can see that A star B into C should be equal to A into B star C. Now let us take one example. A B I will take as 1 into 1, that is 1. Okay, 1 into minus 1 I will take. The answer is I got minus 1. Now same way, this I took as A, this I took as B, this I took as C. So now A into, first what I will do, B into C I will do. 1 into minus 1. Okay, let us tell this 1, 1, minus 1. So 1, 1, this is minus 1. So 1 into 1 is 1, then 1 into minus 1, the answer is minus 1. Then 1 into minus 1 is minus 1. Again 1 into 1. 1 into minus 1 will give me minus 1. So that associative, you can see it is getting proved. So 1 is W4 and is the identity element under X. So we can see here from here, since all the elements multiplied by 1 gives the same number, so I can say that 1 is my identity element. Now, and I should also prove that A into A inverse should give me identity element, that is 1. Okay, so 1 into 1 inverse. So see here, inverse of 1 is 1, that is 1 inverse is goes to 1. Why? Because 1 into what will give me 1? So 1 into some A inverse will give me 1. So I know that 1 into 1 itself will give me 1. So I can say that 1 is my inverse of 1. Then for minus 1 into A inverse should give me 1. So minus 1 into minus 1 will give me plus 1. So minus 1 is the inverse of minus 1. Same way, I into A inverse, some inverse should give me 1. Okay, so I into, now we know that different sign. So I into minus I. So for I, minus I is the inverse. Similarly, for minus I into A inverse, I should get 1. So minus I into minus if I do, I get minus 1. So I have to do here plus I. Signs will be different. So I can say that for I, for okay, 1 is 1 itself. So each number is inverse to each itself. Okay, so I can say that W4 is an abelian group. Okay, I prove that associativity, commutativity like that. Okay, now another question I have, let G be the set of all non-zero numbers and let A star B is equals to half into AB. Show that D comma star is an abelian. So G is an abelian. So now see here, we have defined that A star B is half into AB. So now if for it to be abelian group, I have to show that it is what to say, reflexive, that inverse. See here, for any two non-zero real numbers A comma B, we note that half into AB is also a non-zero real number. For any A comma B belongs to G, A star B belongs to G. So G is close under this binary function. This thing norm common will write. So now first I have to show that associativity. Okay, A star B star C should be equal to A star B, okay, star C. So now I know that. So from I have to write. So A comma B comma C belongs to G. So now what to do? I have in the given question C, you can see here this they have given. So now first I have B comma B star C. So in place of A I have B, in place of B I have C. So I'll write half into B into C. Okay, you understood, right? Now I have this equation now. So this is my A, this is my B now. Okay, this is my A. In place of A I have A, in place of B I have half into B into C. So what will that become? Half into A into B. Half into, what is my A? That is A. So what is my B? That is again half into B into C. Okay, that's what they have written here. Then what I will do? I will just multiply this half into B into C with A, so that is nothing but ABC by 2 into 2. So now what I am doing here, I'll remove this C outside. Okay, AB by 2 I am writing here as it is. So what I'll do, AB by 2 is nothing but, okay, I'll write, so half, this is nothing, this thing, after this what I'm doing, half into AB, I'll group like this, into C I'll group at it, then again this half I have as it is, okay, half into that. So now you can see here, this thing is equivalent to this right hand side of the given formula, right? So half into AB, so half into AB I can write as A star B. That's what this thing has become this simple. Okay, then what do I have? Half into A into B I have. See here, half into A into B. So I can simply write it as this A, see, half into, now this is my A term and this is my B term. So I can say simply write as A star B, which is nothing but A star B is my A and then becomes C. Understood, right? I tried to explain it in simple way, how it is different being different. So thus star is an associative. Now I have to prove, what do I have to prove? Identity element. For any A belongs to G, we have, okay, so A star E should give me, what to say, is equals to A itself I have to get. So, and I know that A star E is nothing but half into A into E. So now my this E should be such a number that I have to get only A. So if I take E as 2 now, so see, where is this thing? I know that half into A into B. So I have to take this value of B such a way that I will get the total sum resultant answer will be only A. So that's why I'm taking I'm taking 2 such that A star 2 is equals to 2 star A because of associativity, which is equals to half into 2 into A. Here 2 gets cancelled, so only A is remaining. So I can say that 2 is the identity element. Then now what I have to say? I have to show that A A into some inverse should give me identity element. What is my identity element? That is 2. Okay, so I know that A star B is nothing but half into A into B. Instead of B, I have A inverse. Okay, I have to write the value of this should be in such a way that I will get only 2 as my answer. Now see here, I have divided in the denominator here 2. So if I take 2 here, that will get cancelled. But if I take 4 in the numerator, somehow, just I'm just saying. So let me just write here. Okay, half is there and A is there. I have, if I take 4, so here this will get cancel, here cancel, so 2 is remaining, but still I have A. So let me take 4 by A. So if I take 4 by A, so see here, 1 times, this will become 2 times, then cancel, cancel, A and A will get cancelled. So I resulted answer I am getting 2. So what will take? So I will take my A inverse as 4 by A. So if I substitute that in the given equation, then I will get 2 itself. So I will say that thus the above facts show that G comma star is a group. Further I can say, so I have to say that it is what to say, commutative, which means A star B should be equals to B star A. How? Now I know that A star B is equals to, now see here, half into AB. Now A into B is equals to B into A. So I'll write it as is equals to half into BA. Okay, this came by mistake, we don't want this. Now I can say that half into BA is similar to, is equivalent to B star A. Okay, so I have proved that it is a commutative also, therefore G comma star is an abelian group. Same way, prove that a group G is abelian if and only if AB the whole inverse is equals to A inverse into B inverse for all A comma B belongs to G. This is a very simple thing. This is like you'll be like, after solving this, oh, only this much I have to do. But it's very simple, much on. So first, what I'll do, I'll suppose that G is an abelian group. Okay, I'll consider suppose it is abelian group. Therefore, A comma B belongs to G. which means, so now what I'll take? A inverse into B inverse is equals to B inverse into A inverse. This commutative thing. Here they have written, see, AB is equals to BA, which means it is commutative. So now I can take uh, B inverse into A inverse as AB inverse, which is nothing but, see, I one more thing I'll write, which is equals to B into A the whole inverse, which is equals to AB the whole inverse. Okay, this thing I have derived now. Here B inverse into A inverse equals to AB the whole inverse in the group, which means first it will become this, then AB is equals to BA, so BA will become AB. Now conversely, suppose that AB the whole inverse equals to A inverse into B inverse for any x comma B belongs to G. Then for any x comma Y belongs to G, A comma B belongs to G is there. So instead of A B, now what I'll do? I'll take some x comma Y, some random variables which should be belong to G. So xy is equals to xy. Now previously in further some theorems we have proved that x is equals to x inverse again whole inverse. Okay, so here what will happen, uh, for example, if I have to say that that negation was there, right? Negation p is there, then whole again negation of negation p is equals to p. That's why some same way x is equals to double inverse of x inverse the whole inverse. So I can write in that place now, see here, so instead of x into y I'll write x inverse the whole inverse into y inverse in the whole inverse. Now see here, powers are same, so what I'll do, I'll group the bases. That is nothing but x inverse into y inverse the whole inverse. Then I'll it is in the form of AB. AB is equals to BA. So I'll write off y inverse is into x inverse the whole inverse. Then again what I'll do? Then again I'll imply this power inside, which is nothing but y inverse the whole inverse into x inverse the whole inverse, which is equivalent to y into x. Therefore, I have proved that x comma y is equals to y comma, that is commutative. Understood, right? What we are doing here. So only this much you have to write. So you have to prove the thing. You have to prove that A is an Abelian group. So if and only if AB inverse is equals to A inverse into B inverse for all A comma B belongs to G. You understood, right? What I meant. So first I took, see, I have to say that AB is equals to this. I have to prove. How I proved it is, I took first, instead of first I took this thing. Okay, then I set it as, or else you can take like this also. You can start from here also. If you start from here, I say first we are starting from here. This is equals to A into B. So it is a form of A into B. So I will write it as B into A. Since powers are same, then I'll multiply the base. BA is the whole inverse. Okay. Then I can write as BA is there. I can write BA as AB. Same cheese if you write ulta, from this step to this step, from here to here, then from here to here, that will be same. Then we have to conversely prove that AB inverse equals to A inverse or B inverse for any A comma belongs. So you have to take x comma y. You have to prove that xy is equals to yx. So this is the step done. Then another we have show that the identity element of G is unique and the inverse of each element is unique. So for all the elements we'll be having one same identity element, for all the elements I'll be having one each for a same inverse element. Okay, suppose E1 and E2 are identity elements in a group. Okay, so I'm considering two identity elements, that is E1 and E2. Okay, in a group. So since E1 is an identity element of G, therefore A into E1 is equals to E into A1, which is equals to E1 itself. Okay, here E1 is an identity element I'm saying. Okay, for all A belongs to G. Since it is here, you can simply write A also you can write. Okay, thus this is true for A is equals to E2 because E2 belongs to G. Then E2 into E1 is equals to E1 into E2, which is equals to E1 itself. Okay, we can write here E2 also here. Identity element we are proving, right? So any number into identity will give us the same this number itself. It will give me 1 itself. So should give me identity itself. Okay, any number into identity, any number into identity will give me identity element. Since here I have E1 as my identity element, anything into identity element will give me that identity element itself. Okay. Same way, first I consider this as my identity element. Now what I'll do, I'll consider this as my identity element. Let us see what I'm getting now. Thus E1, now see here. Similarly, E2 is an identity element of G. It shows that E1 into E2 is equals to E2 into E1, which is equals to E2. Okay. Now what I can do? Thus E1 is equals to E1 into E2, which is equals to E2 into E1, which is equals to E2. Okay. Same thing as well. So see here what I'm doing. Like this, if I take, I'm getting E1 here. See, like this, if I take, I'm getting E2. See, so I can say that LHS is both same for both. LHS is same, therefore I'll say that RHS are equal to each other. RHS is also same, so E1 is equals to E2. Since E1 and E2 are same, then we cannot say that it has more than one identity element. So only one identity element is there. Okay, that's the actual explanation. Now I have to show that it will have only the inverse of each element of G is unique. So what I will do, suppose let E be the identity element. So I am taking E as my identity element. Suppose now I am taking two inverse element, that is A1 and A inverse and A double inverse. So A inverse and A double, A dash and A double dash as are inverses of an element A belongs to G. So first what I will do, A inverse I can write as A inverse into E. Why? Because see X is equals to X into E. It will give me X itself. For all X belongs to G. From one theorem we have proved. In general it is. Then I can write this E is equals to A into A inverse. A into A inverse is equals to E. I know that. Since I have already taken this A dash, so I will take instead of this is also inverse, so I will take A into some inverse, that is A double dash. So E can be written as A into A inverse. So A into A double inverse I have taken as A double dash. Now I have A dash here and here. From associated property, what I will do, I will group A dash and A. A into A dash I have written, right, since A into an A inverse is nothing but identity element. So A into A will give me E. Now what I have, E into A double dash. I know that identity element into something will give me that something number itself. So E into A double dash will become A double dash itself. Therefore, two inverse elements I took, which is equal to each other. Therefore, it is not unique. It both are same, na? So therefore, it both are same. So both are not distinct. Therefore, I have only one inverse element which is unique. That's it. Then see here, this is one question. Just read the question. Remember what they have given. A star B is equals to this they have given. Okay, so now what I have to do? I have to show that it is an Abelian group. So what I have to do? I have to show that associativity first. A star B star C. So I take like this, it is equals to A star B star C, like this. Then I have to get one identity element E. I have to find an identity element E such that A star B will give me A itself. Then I have to find an inverse element such that A into B will give me, how to say, this identity element will give me identity element, whatever the identity element I get. Then I have to show that A star B is equals to B star A. If I show all these things, then I can say that it is an Abelian group. Now let us start. So first what they have given, I am considering A comma B comma C belongs to G, to show that it is first to show associativity. Now I let me just write the formula here. I'll erase this. You understand what we have to do. Okay. Now let me draw. So here they have given A star B is equals to A plus B plus A into B. Now I have in place of A star B, I have B star C. So it will be B plus C plus b into c. That's what they have written. So now this is my a and this is my b. So what I'll write, a plus b, this whole thing b plus a into b. Same thing, a plus b, this is whole thing is b plus a into b. Now you see here what I'm doing, I'm just removing the brackets. Here I'm removing the bracket, here I'm just multiplying ab, ac, abc. Okay, here. Now what I'm doing here, I removed the bracket and I multiplied it. So now what is happening? Let me just tell you in a simple verse. What I'm doing here is all the terms which has C, I'm writing towards the right, and which don't have what to say C, I'm writing first, which is nothing but A B A B. I'm writing first here as it is. Then plus C will be as it is. Then see where which is term having C, I'm writing here B C A C A B C. In this what I'll do, I'll take C common now. If I take C common, then what is remaining? A plus B plus AB. Now I'll rearrange this. How I'll rearrange? I'll rearrange down C plus A plus B plus AB, right? Plus C into A plus B plus AB. Now see here, this is in the form of that actual equation. Okay. What I'll do one changes. Okay, I'll write it as like this. This itself, same thing I'll do. So now, simply I wrote this much, waste of time. I have to prove, I have here A star B star, so I have to prove it is equals to A star B whole star C, right? So now, I have this as my A, this as my B, and this as my AB. So what I can do, I can simply write it as A star C. So that is nothing but uh, A plus B plus AB star composition C. Then again further I can first write like this. Then what you do, explain. Now you see this is my A, this is my B, this is into AB. So I can write it as A composition B. So inside the bracket it will become A composition B composition C. That's it. So I have proved now. Now I have to prove the identity element. So I have to take identity element such that A star B will give me A itself. So I have to select a value of B in such a way that, so now see here, I know that A star B is equals to A plus B plus A into B. So I have to select a value of B in such a way that only A will remain. So if I take 0, so see here 0, if I take A into B, this will become 0, this will become 0. So what is remaining? Only A. So I can say that 0 is my identity element. That's what is happening here. Then what I have to prove? A into A inverse will give me identity element. That is, since my identity element is 0, so A into A inverse should give me 0. So I have to take a value for A inverse in such a way that, let me write it here now. A plus A inverse plus A into A inverse will give me 0. Okay, I have to take the value of A inverse in such a way that I will get 0. So you have to just what to say, if I have to say by heart the value of A inverse here, that which is nothing but A divided by 1 plus A. Because if you sit and try to solve in the examination hall, it will take more than 10-15 minutes or half an hour. So it is a waste of time. So just remember, this is one unique question. So obviously A inverse will be A by 1 plus A. How? I think I had already multiplied. See, done it over here. Let me erase these extra things. Now see here, if I am considering A minus A, instead of A in the inverse, the value of A inverse is minus A by 1 by A. Then plus A into A inverse is plus will become, so since I have minus in this A inverse, so it will become minus into A inverse is nothing but A into A by 1 by A. Okay, let me write here. A into minus A divided by 1 plus A. So that is nothing but A into A is A square minus A square plus 1 by A, minus A square plus 1 by A. Now what I am doing, since this base is same, I will just add this 2. So that is nothing but A minus A square. I have minus A here. Okay, So what I'll do, cross multiplication. A into, see, A into 1 plus A. Okay, I'll have like this. I'll write here A into 1 plus A minus A square. So A into 1 plus A I have written here. A into A is A into A is A square. A into 1 is A into A is A square. Then minus A square. So see, this cancels, this is cancelled. So I have 0 in the numerator. 0 by anything is 0. Therefore, I am getting for A dash is equals to minus A divided by 1 by A belongs to C, which gives me identity. Then I also AB is equals to A plus B plus AB. Okay, A plus B plus AB. A plus B plus AB. What is that? A star B, right? That like this, which is equals to B. So A plus B can be written as B plus A plus AB can be written as B into A, same value, which is equals to now B into A, which is B star A. Or here you can say simply write A star B. Done. So this says that it is what to say Abelian group. Okay, so on a cyclic group and Coset and Lagrange's theorem, I'll try to do it next lecture, or else I won't do. I'll do, man. Don't worry, I'll do. But the only problem is, sorry for that. I'm doing so late. It will be a problem for you all to study also, right? I'm just sorry for that, but for different semester student, it will be helpful. Okay, the ones who are seeing this after half a year or after more than a year, after a certain period of time, don't get confused. This video I'm making right now, the date is like 2004. Okay, the fourth semester. According to 2022 scheme, we are this 2022 batch. It is for 4 semester. So if you are from 23 batch, you will be like confusing what I am saying for other this student. Okay, for you guys, I think already the videos will be available 2023 batch. So I'm doing this one for 2022 batch. Okay, this part I will do in next lecture.
Can I please ask you to subscribe? That's all we want, man. Just press subscribe.